Good morning and thank you for joining this webinar. My name is Mario Centeno. I am the product marketing manager for the i.MX RT series. Can you go to the next slide, Johan? When we put together this webinar, we wanted to give you guys a little insight into what we're doing around the RT series. It's been around for a little over, I guess, just about 2 years. So we wanted to share some insight into what we're doing and the value proposition that we're bringing to the market. One of the unique things with the RT series, or actually within NXP and the industry, is within the same business line, we have a organization that manages MCUs and application processors. So MCUs going down from our LPC Kinetis line all the way up to our i.MX and LayerScape products, so more complex devices. And what that's allowed us to do is share a lot of knowledge in terms of the customer base, share knowledge about R&D resources and software resources. And that's really what the genesis of the RT series is about, is taking the best of both of those worlds, what we have from the application processor side and from the MCU side. The crossover MCUs are really meant to target those customers coming from the MCU space that need more performance, that want to drive more into their applications, whether it's graphics or any other of the attributes that come along with the RT series. And for the application processor guys, it's really meant to bring them into the MCU world without them sacrificing the performance and features that they're used to. So again, it's really taking the best of both worlds and combining them within an application processor framework or chassis using MCU cores and MCU software and ecosystem. Next slide, please. So as I mentioned, the RT series has been in the market for about 2 years. Our team has been fairly busy expanding that family. If you look at this slide, it basically is a timeline of what we've done over the last 2 years. And within that 2 years, we've taken the family from one product, the RT1050, which we're going to demonstrate today, and expanded that to 7 products. So on the top side, we have a kind of outline the history of the major milestones. So the RT1050 was introduced in October of 2017. It was the first time an MCU hit the performance of 600 megahertz. We announced on the top side, the RT600 is where we started integrating true DSPs into the RT series. And then the bottom section of this chart is stuff that we've done to build on these families. So off the 1050, we've introduced products with more memory and also products with reduced feature sets and lower cost. On the far right, we have some application solutions that we've built on these products. For example, you might be familiar with the product that we announced in the middle of June. It's the RT1060A, which is the first MCU platform in the market that runs Alexa voice services, and it's a certified solution. Last month, we introduced 2 other solutions. One is centered around facial expression and recognition, and then the last one is a 1060L, which is local voice control. So that's what we've done with the RT series in the last 2 years. If you look at the top right, we had an announcement last week at ARM-TechCon where we announced the RT1170. So that's now where we're reaching into the application processor level of performance. So we announced the RT1170, which is the first gigahertz MCU in the market. Johan, can we go to the next slide? So this slide is meant to depict some of the applications or customers that are in production today with the RT series, and it's really become a mass market play. And with these RT crossover processors, where we're able to pack a lot of features into the devices, we've really found a lot of homes or applications for the product. But if you look at it, if you scan anywhere between the voice, audio, consumer healthcare, home automation, there's always a UI involved, and this is where the work we're doing with our partners like Qt and the features that we're putting into the RT series come into play. Next slide, please. So this is a superset block diagram meant to depict all the features that are available on the RT series. So there's traditional MCU features like timers that are used for motor control. There's some audio features that come from the i.MX world for advanced audio products. There's some connectivity features like SDIO that are meant to be used to connect higher bandwidth Wi-Fi to these applications. But in particular, I want to highlight the sections in the middle. So what we do with the RT series is, we really push the performance. So in this case, we're looking at the RT1060 superset block diagram. So running at 600 megahertz, uses the Cortex M7. We put a lot of memory on the devices. So in this particular case, on the 1060, we have up to 1 megabyte of SRAM. We have versions that have either more or less memory on board. So the device that we're going to demo today is the RT1050, which has a half a meg of SRAM on board. But we also have an RT1064, which has the 1 megabyte of SRAM and 4 megabyte of flash on the device. In the middle, we have a section called the multimedia section, and this is where we add peripherals that come from our application processor side. So in this case, we have a camera interface, LCD controller interface, and a 2D graphics acceleration engine called the pixel processing pipeline, or the PXP. And really what this allows for is, it's a 2D graphics acceleration. It allows you to resize, overlay, and rotate your images. And then with the RT series, we put these external memory interfaces to allow us to interface to either a quad SPI flash or SDRAM through the device. And with that, let me hand it over to Johan, and we're going to go into a demonstration using the RT1050 platform.
Hello, everyone. So yeah, today's topic is going to be Qt for MCU. And specifically, we are going to look at how you can get started with Qt for MCU. So before that, I'll give you a first short introduction on what it is exactly and what it includes in the 1.0 release. And then we'll move on to the live demo. And again, you will see all the steps that you need to get your first Qt application running on a MCU board. But before that, a also short introduction on what Qt is. Maybe there are people now here that do not know what Qt is. So Qt is an all-in-one application framework to basically cover all your development needs for developing on pretty much any platform that exists, from desktop to mobile to embedded. It's mainly C++ based, so or at least you have APIs in C++ for pretty much anything, but it's also based on the QML language, which is specially designed to do graphical user interfaces. It is, as I said, fully cross-platform, so that means that you just write once and then deploy anywhere where Qt is supported. And I will show you in the next slide what are these platforms. And finally, you have also development tools in addition to the framework or the APIs. And mainly these are the Qt Creator IDE, which I will show you today, to do development, debugging, profiling, and so on, as well as design tools to improve the development workflow, to go from design to production with one tool chain. And these ones specifically, which I will not cover today, are Design Studio and 3D Studio. This is the list here of all the platforms we support in general in Qt. We support the main embedded operating system that you see today in embedded devices, so embedded Linux or Windows embedded, but as well as some real-time operating system like i.MX, VxWorks, or Integrity. Of course, Qt supports desktop. This is the origin of Qt. So Windows, Linux, and Mac. mobile as well. And something which is new is the web. This we have released in since 5.12 last year, where Qt can be, or any Qt application, even one that has been initially designed for desktop, for example, can simply be recompiled for WebAssembly and then made available to run inside a web browser. But today's topic is MCU, and this is really for Qt, a new platform. So it's embedded, but it's a special type of embedded device because it has much more limited resource that the typical targets where Qt would have been used until now. We actually did some proof of concept more than a year ago to try to run the regular Qt libraries on a microcontroller-based board, but there were several issues. The first one was that, well, Qt requires a POSIX compliant operating system, which is, well, something which is normally and often not used on microcontrollers, even though there are operating system available to do that. And then the other one was that regular Qt libraries are, well, let's say just too large, too big for microcontrollers. We were not able to go below 10 megabytes of RAM on a simple Qt application. So this is why we took a new approach, and we decided to keep what makes Qt very powerful and easy to use. That is the Qt Quick framework to design user interface. And we remade a new runtime for Qt Quick, specially designed for running on microcontrollers. It's called the Qt Quick Ultralight runtime. And it's very lightweight. It's much smaller. I will show you a demo after and tell you how much it uses in RAM. And the other key difference of this new runtime is that it does not depend at all on any operating system. So that means you can also run a Qt Quick application on bare metal. And if you see if you look at the image now on screen, you see there's another difference, and at least that's what's in scope for the 1.0 release and for the following releases. Qt for MCU only includes a GUI framework, so it's only Qt Quick, and you do not have access to all the regular Qt libraries that do, for example, networking or database access or anything like that, which is not graphical user interface. So for that, when you're using Qt for MCU, you would need to use other third-party C++ or C middleware libraries. So what's in the Qt for MCU 1.0 release? Some of you maybe have tried the evaluation release or the beta release we did back in end of last year. There are some differences in the 1.0, or some things were added basically in the 1.0 release. So let's go through that. Of course, it includes the ultralight graphics runtime that I talked to you about, but it also contains different Qt Quick APIs, and in addition to the basic one, it contains the Qt Quick controls, which is a set of common widget, if you can say it this way, like push buttons or switch or checkbox and so on. It is fully stylable, and you can apply themes to this. If you don't, then it will have a default look and feel. It has also different platform adaptations. As of the 1.0 release, these are all for bare metal, and they are for different boards from NXP, STM32, and Renaissance. It also has tooling integration for now, the Qt Creator integration, which I will show you today, where we'll do all the small project based on this. And it also supports localization to translate your UI to different languages using the linguist tool. And specifically in the 1.0 release, it supports left to right languages. So for example, it excludes Arabic from translations. And of course, it has an extensive documentation on how to do things, and as well as examples with source code. So let's get started with Qt for MCU. If you have everything ready, you can also follow along this webinar and try to reproduce all the steps that I'm doing now. Otherwise, well, you can just watch it, and we are, as Sala said, recording this webinar, and then you can do it later, maybe with a bit more time. So what you will need for this webinar, it's one of either two boards, which are the two we provide a platform adaptation in the evaluation with an evaluation license for this. The first one is from NXP. It's the i.MX RT1050 evaluation kit, or you can also use the STM32F769i. So today I will show you again both, so that you can use either of them. There are also some hardware requirements which are listed on the screen now. I'm not going to go over all of them. Again, if you need if you want to do it yourself, just install all of these. Something which is important maybe is that today you need Microsoft Windows. The environment is not available yet on Linux, for example, or on Mac. And you need to have CMake because Qt for MCU is based on CMake, not on QMake. So let me show you now where you can get the Qt for MCU package, because of course, if you want to try that, you will need to get it. If you already have a Qt license, Qt for device creation license, or maybe even an evaluation license, it should already be included inside the installer. So here I have the Qt installer run, and you can see that there is a Qt for MCU category with the package. If you do not have any license, then you can contact us to ask for evaluation license. And then so make sure that you have this package checked. But also, and this is important, you will need to install Qt 5.14 as well. This is required for the translation tools. So yeah, just pick the one you need, either based on Visual Studio, like I did here, or based on Meet Debug. And by default, it will also install Qt Creator as well. And once you have installed that, you will have, of course, Qt Creator installed. And if we have a quick look at what the Qt for MCU package contains, you will see that it has, well, all the tools you need to build a Qt app. It has also pre-built demo images for the STM32F7 and the NXP 1050. I can actually show you right now how it looks like. So now you should be able to see a live camera feed that shows a board on my desktop. And well, this is one of the demo we provide, which is running at a smooth 60 frames per second with different UI components and so on. It has translation support, so you can change to German language. And as I said earlier, Qt for MCU is really designed to be as lightweight as possible. So to give you an example here, this demo that I'm showing you right now is just the program. The binary is a bit less than 200 kilobytes. And if you add the assets to that, all the image assets, then that's an extra more or less 1 megabyte. But again, the program is less than 200 kilobytes. So you get that with the package. You get some other examples as well that you can try. And of course, all the library, pre-built library. You do not get access to the source code of all of Qt for MCU. And of course, the documentation. So let's now create our first Qt for MCU application. But before I do that, there's one step that you need to take care of to be able to run everything correctly. and that is to set a environment variable so that everything works. So let's do that now. Let's edit the environment variables, and all you need to do is to add to your path the path to the Qt 5.14 installation. So the one actually for desktop. And so this will be required to find the translation tools. And once that's done, you can close that, and then we can open Qt Creator. And before we create the project, there are a few steps that you need, or a few configuration steps that you need to do. The first one is to go into the About plugins here inside the Help menu and enable an extra plugins, which is not enabled by default. That's the bare metal plugin. You can type here, just type bare in the field at the top, and then just check this box here. You will need also the MCU support plugin. This one should be enabled by default, but just make sure it is. Then we close this, and we actually need to restart Qt Creator so that it takes effect. All right, then the next step is to configure the kits, what is called a kit in Qt Creator, so that you're able to build a Qt application for the MCU board. For this, we go inside well, the kits will be here basically. Right now, they are none. There's just the desktop 5.14 kit. And to create the one with the ones for MCU, we need first to go in the device section here, and then inside the MCU tab. And there are a few paths that you need to configure. That is the path to the GCC compiler, as well as, depending on which board you want to use, the path to the board tools. So in this case, it's for STM32. If you want to use the i.MX RT1050, you will need to set the path to this Sager J-Link tool. And of course, the path to the Qt for MCU installation, but these should be detected by default. Same for the Sager J-Link and the STM32Cube programmer. If you leave the default installation path, it will be detected automatically. So all you need to do is to find where your GCC is installed. In my case, it's here. Make sure you use the latest version, because some previous versions are known to cause compilation issues. And once that's done and everything is green here, just click the apply button here. This is what will actually create the kit. And in this case, since I will show you on two different boards, I will do the same for the i.MX RT1050. We'll also click apply. And if I go in the kits, now you see I have my two kits for STM32 and for i.MX. So if you only want to develop and run, that's all you need. If you also want to do debugging from Qt Creator, there's an extra step you need to do, and I will show that to you now. Let's start with the NXP one. And the reason is that the MCU support plugin doesn't yet support debugging. So you need to use another plugin, which is the bare metal one. So we need to configure it. We go into the device section again, and then we go in the bare metal tab, and we need to configure how GDB will be used by Qt Creator. So let's do it for the two boards, and let's start with the NXP one. Let's create a new GDB profile, and let's call it J-Link, because this is what we will be using. I will just change the port, because that's just a setting I'm setting in the server. Click that, and then there are init comments that you need to set here. I will just paste it now, but well, we'll need to write that down as well. It's also detailed in the documentation, the full list of these comments, and the same in the reset comments. Then just click apply, and then we need to go inside the device here, devices section, create a new device, which is of type bare metal. We can call it i.MX 1050. We select the GDB profile we just created and then finish. And then the last thing you need to do to be able to do debugging is to have a new kit. So this is what I recommend. Otherwise, you would need to always change the device type here for your existing kit. So I think it's just easier if you clone the kit here. You can just rename it and add something so that you know that it's for debugging. Just call it this way. And you just need to change the device type to bare metal, and it will automatically pick the right device. And now we all set up to create our first project. Remember that all these last steps, which were a bit long maybe, are only necessary if you want to use debugging or to do debugging from Qt Creator. So let's create a project. For this, you can go inside the File menu here and click New File or Project. And this is one of the new features we have in 1.0 compared to the previous beta release. There's this MCU support application that you can choose. Let's select where we want to put this. Make sure you use a path that doesn't have spaces in it, because I believe there might be some issues with some of the tools that are being used otherwise. Let's call it Hello World. Next. And here you can select the kits for which you want to build your application. In this case, I will build it for the two boards I have. So the NXP i.MX 1050 and the STM32. I will actually also select these kits to do debugging. And then just finish. So the MCU or Qt Creator will basically create a ready-made project with a sample QML file, as well as the project file, which is a CMake file. And for people who know about Qt, this is one of the key differences. Qt for MCU always required CMake. I will go over some of the important points here and also give you an introduction to the QML language if you do not know how this works. But before that, let's just check if, well, this application can already run on our board. So I have the ST board now up and running that you should be able to see here. And let's just select the kit you want to build for. In this case, it's the STM32. I do not need to debug at this point. Let's select the release build. CMake will be run. And a small advice to save you some time. There is actually currently a bug when using the STM32 device. You will need to go inside these project settings here and then select the STM32 kit and then the run settings. And in this text field here, you will need to remove this last part. Underscore and underscore bootloader. You do not need to do that for the NXP board. Just change that. And then you can just click run. CMake will be run. Then it will compile the different files we have. And automatically flash to the board as well. And now it's running on the board. So for now, it's a very simple example application, but it works. Let's try as well on the NXP board. We have the same demo application, and all we need to do to try the same application on the NXP board is to simply change the kit. And same thing, you can just click. By the way, if you open any of the included example, that's all you need to do. Just open it, build, run, and that's it. Let's click run. It should be the same thing. CMake is being run, then the compilation. and then the deployment. And it's running here as well. Hopefully you can see the text. I think is a bit small, so you might not see very well. I will go back to to using the SD board to save some time in this webinar. I won't switch between boards for every step that I do. So for the rest of the webinar, I will be using this board. All right, so let's have a look at what this project contains. First, let's go inside the project file, so the CMake file. There are some important things here. You will notice, and this is a requirement, you will need to use CMake 3.13 at least, or higher, basically. And then there are a few things that are required in your CMake project. You will need to find the QUL package, which stands for Qt Ultralight. And this is where it will find the correct libraries. And then there are two key comments that are done here. The first one is this one, which is the cool target QML sources, where you add QML files to your project. So for every new QML file you will need to add to your project, you need to add it here. And finally, you need to link to the Qt Ultralight library, which is done this way. And over detail, if you include C code inside your project, like we will be doing today to access the hardware, make sure to add also this here to avoid some compilation issues. And now if we go into the QML source file, let's go over a bit what's in there. And this will be, of course, mainly useful for anyone who do not know at all about the QML language and Qt in general. So QML is a really easy, I would say, to learn language. It's much higher level than C++, and it's really one of the main advantages of this language. It's higher level. It's very fast to use. It looks somewhat similar to JSON. You have a list of objects which are declared in a hierarchic way, and each object has properties and values. And one specificity is that values do not necessarily have to be static values. They can be scripts or bindings, as we call it. And I will show you later how do you use that. So in this base application, we have here a rectangle and a text. And the rectangle is always the root item. There's a size, which is set here. This is actually optional. If you deploy on board, it will always fit the complete screen. So this is actually optional, only necessary if you want to try on desktop. Because you can also, I didn't mention it, you can try your Qt for MCU application also on desktop, on Windows. And then inside, there's the text element. Very simple here. I think it's fairly straightforward to understand what it does. We set the color to salmon. And the actual text value is hello world, and the font size is 14. And one important thing here is that we center the text to the rectangle. One comment here, which is important to notice for people who already know QML, is this line here, the pragma main. This is not required in normal QML code. When you use it, for example, on embedded Linux or on Windows, you do not need to do that. But when you use QML on Qt for MCU, you will always need to write this line inside the main QML file, basically the main entry point. So let's change a few things in here. First, we will change the color of the text so it's a bit more visible. Let's make this black, just like this. And let's make it a bit bigger as well. So let's instead put a pixel size of 24. Let's select back our STM32 kit. And let's just try to see how it looks like. building and then flashing. So you might see this error sometimes. This is an issue with the SD link flasher. So if this happens, just rerun it. Sometimes it happens. Well, in this case, it happens twice in a row, or 3 times in a row even. If you still have this problem, you can also manually just reset the board here and it should work. Okay, so now we have our new text running, just a bit bigger and blank. Okay, this was easy. Now, how do you do if you want to use a custom font? Because here I did not set actually a font. So if you don't do that, it will just use a default font, which is included with Qt for MCU. But if you want to use something else, what you need to do is to add all your needed fonts to your project. And this is what we're going to do now. Let's go to the project directory. I have my project here. That so far only contains this. And I will copy some fonts inside my project. There's only one. It's the Montserrat font. And then what you need to do is to go back inside Qt Creator, and you need to tell Qt for MCU where to find your fonts. So let's go in the CMake file, and then you need to add two lines. The first one is this one, where you set the variable cool fonts dir to where basically the font is. So in this case, it's the font subdirectory inside my source directory. And then there's another one you need to set, which is the cool default font family variable. And in there, you need to set it, well, basically the default font family. In this case, we have only one font, so of course it should be that one. And that's actually enough if you need only one font throughout all your application. But let's say you have multiple ones, and I would have added, for example, 2 different ones. You would still need to set the default one here. But then in every text element that you have in your QML code, you would also need to set the font family property to the name of your font. In this case, Montserrat. And then now, if we rebuild this project, I made a mistake somewhere. All right, it should be all right now. Actually, I'm still have one quote too much. Sorry about that. All right. And now if we build it and run it, we should have our text updated with our new font, custom font. All right, so you might not see the difference because the font is not that much different, but now it's using a slightly thinner font. Okay, so we have seen how you can add text to your application. Now let's see how you can add images. So of course, again, same thing. If you want to use images, you will need to add some assets to your project. So let's go back to our project directory, and I will copy some images in there, which right now is simply a Qt logo in the PNG format. Let's go back here, and all I need to do is to add an image type. This is how we add an image to your QML project. And all you need to do to show it is to set the source to the correct location. You need to use relative paths in QFrame always, and then your file. And again, this should be enough. We'll just compile. Maybe an explanation how it actually works for both fonts and images. In both cases, it will actually generate all the assets and include it in the binary. So it's not going to load PNGs at runtime as of today, nor is it going to load the fonts. It's all basically converted into a format which is read by Qt, and it's included in the binary so that it's faster to load at runtime. Okay, so now we have our logo here. But, well, that's not exactly where I want it. So how do you position item? There are different ways. You could just set, for example, the X and Y position. So that would be a pixel position. But I would say this is not the best way because it won't be scalable. If you need to have your UI reused in different devices, and this is, by the way, again, one of the main points of Qt, then you should not do that. You should use instead dynamic positioning or reactive positioning. So there are different ways to do it. You could use anchors as it's done here, or you can use layouts as well. And this is what I'm going to use here. So you have different way to lay out items, but here I will use column positioner, where I basically put my text and my image inside that column. And they will be automatically positioned in a column. I only need to remove this here. And instead, I will center the column, and then each item is in there. There's also a few other properties that I can set, the spacing, for example. So with 16 pixel spacing between the text and the image. And what I will also add is how they are horizontally centered. So for that, I can use the anchors.horizontal center, and I do center it on the parent. I can just copy that and paste it to the image as well. And let's run this. Okay, so now we have our logo and our text, which are centered and aligned vertically. Let's go over some a bit more advanced topics inside Qt for MCU. So now it's how do you add some widgets to this, like again a button or a checkbox and so on. As I said in the introduction, Qt for MCU comes with the Qt Quick Controls module that you can use to create all of these widgets. So to be able to use it, you will need to add some new library in here, which is called like this. I will paste it here. So if you want to use the Qt Quick Controls, just make sure you link your application to this library here. And one comment about this, if you look at the name, you see that it's called Controls Style Default. So this is the one to use if you want to use the default look at it. If you want to customize it, it would have to be a different one, which is documented. So just have a look at that. Then we can close this. And then in the QML file, the only thing we need to add is to import the correct module. So quick.controls 2.0. By the way, this is a detail, but for, again, people who know about QML already, in Qt for MCU, the version number is optional, so you do not need to put it. If you just remove it, it will still compile and work. And then, well, we are ready to add some other items in here, and let's add a switch button. which will be also vertically aligned in our column in between the text and the image. We'll do the same thing as this so that it's centered horizontally. And then, well, let's do something with it. And this is a good occasion to see one of the probably most powerful and useful concept that exists in QML, which is the bindings. So in this case, what I want to do is I want to have the image visible whenever my switch button is on. And if it's not, then the image should be invisible. And so thanks to the binding mechanism in QML, you can do that in just one line. So I will need to refer to the switch. So for that, you can use the ID property, which lets you give a name to the element. So in this case, I will call it switch. And then in the image, so to make an item visible or not, you could use the visible property, but you can also use the opacity if you want more control over, well, if you want different levels of visibility. So in this case, what I do is I just write if the switch button is checked. So this is like JavaScript now. This is a scripting. Then the opacity is 1, otherwise it's 0. And now whenever, if I run this, whenever the switch button state changes, this expression here will be automatically reevaluated, and the property opacity will be reassigned automatically based on the new value. All right, so now since the switch button is off, you don't see the image. I click on the switch button, the logo appears, artist appears. So this is easy. Let's do something a bit more advanced. Let's say now we want to animate this. And this is another way, another thing which is very easy to do in QML. It's animations. So let's say that now instead of just going from 1 to 0 at once, we want to do a smooth transition, like it's fading in or fading out. So for this, all we need to do, there are actually several ways to do it, but I will show you one way. One way is to install a behavior on a property. So we should do it this way. So what this does is that you tell, well, whenever the opacity changes, there should be some behavior. And in this case, it is, I want to have a number animation. So the opacity will be animated according to some properties, which I will set now. So I want it to last 600 milliseconds. And then I can also, well, that could be enough already, but let's say I want it to look a bit more fancy, and it's not going to be linearly animated. Instead, I will use an easing curve, and I will use out cubic. And that's it, really. That's all you need to do to animate it. And now, instead of going from 1 to 0 or from 0 to 1 at once, it will take 600 milliseconds and go from basically 0 to 1 and all the values in between. So let's try this. So now you can see that the logo is fading in and fading out when I click. Okay, let's do something even more. Now, let's say we want also to animate the position so that it appears from the bottom. So same thing, similar concept, and now what we need to do is, I will hide this for now. Since we have everything inside a column, we cannot directly change the X and Y position. So to be able still to do this animation, I will need to wrap my image inside another item. This is like just a small trick to be able to do it. And I will make sure that Let's give a name to this image. Let's call it logo. Let's make sure this item has the same size as our image. I bind the size basically of the logo to my item size. I will need to move this here. And now I can simply animate the Y properties like this. So again, same idea as what I did for the opacity. I just set the Y position based on the condition. So if the switch button is checked, then it should be where I wanted it to be in the first place. If it's not visible, I want it to be a bit more down, so 50 pixels down. And for the animation, well, same thing. We can just simply copy and paste this line. And instead of having it on the opacity, now, of course, it's going to be on the Y position. So let's just try this to see how it looks like. I think I should always just press the reset button. And let me show you the camera. And now, all right, we have our logo, which fades in, but also moves from below, from the top, from the bottom. So this is how you can do animation. There are different ways, but then I recommend you to read the documentation on how you can do maybe more complex animation, like with different animations in parallel, for example. So the next step is, I think, very important, and most likely most of you are probably asking yourself now how to do it, is how do I connect all this UI to the hardware? I mean, typically you do not want to do just the UI. It will need to trigger something on the hardware, control it, and so on. So how do you do that with Qt4mc? Well, it's very similar to how you would do it in a regular Qt application. So for that, you need to use C++. And there's an easy way to access your C++ backend from the QML. But it's a bit different than with normal QML. So let me show you how that works. Of course, I'm going to need now to create a C++ class. So let's do that. And actually, before I do that, and not to do the complete steps, I will also copy a few C++ and C files to my project. I have here these two files that I will copy to my project. These are basically, well, actually, it's just a C function that configures some pins and turn on and off the LED, the user LED, which is here. So I'm not going to show you exactly what it does. It's fairly simple anyway. So all I need to do, so this is basically my backend. It has nothing to do with Qt. And I will just add it to the project. So for this, I need to call a different function, which is target sources. I pass the name executable, and then this source files. All right, so we have our two C++ source files. I can actually show you what it looked like. You can see here I just have two functions, two C functions, green light switch on and green light switch off with the implementation in there. So now again is we want to call this from QML. So to do that, you need some wrapper basically, which is similar to the concept of QObject in regular QML. So let's add a new C header file, or C++ header file to our project. Let's call it leg wrapper H, and it's going to be in our project. Right now, when you add a new file, you actually need to add it manually inside the project source file. Let's do this. I have the LED wrapper here. And then let's create our wrapper. So in this class, you have different ways. So you have different options on how you can expose functionality to your UI. You can create components. So you could basically just create a class which expose properties, signals. So these are specific to Qt, but also just functions. And then you can instantiate this component from QML. Or in this case, all I need to do is to expose one function, which is turn on the LED or turn off the LED. So I do not need to instantiate components. I can just use instead a singleton, which will have just one function. So you have a C++ API as well in Microcontrollers, which is for basically creating C++ interfaces. And you can import the singleton type this way. And then we can create our class, which will be called LED. And it needs to subclass the QUL singleton type. You also need to pass as template parameter the name of the class. And really, just by doing that now, anything that I add in this class will be made available to QML. So all functions, but also Qt properties and signals. Here, I just need one function. So let's include our backend, which is led.h. And then let's add our function, which we will call set enabled. Take an argument. Ooh. And whenever this argument is true, then we call our C function to turn on the LED. Otherwise, we turn off the LED, the LED. All right, so we have now our backend, which is exposed to QML, but that's not all. You need to tell the tools, the Qt for MCU tools, how to detect this and how it should be integrated with the QML. So for this, you need to go inside the CMake list file and call one specific function, which is called QUL_target_generate interfaces. So this is the function you need to call for all your basically C or C++ interfaces that you want to expose to QML. So here you just pass all of it. Now we have only one, so this is all we need to do. And another detail, since this command actually will generate some files, you need also to set these two, call these two lines to make sure that the source directory as well as the binary or the build directory are included into the include path. Otherwise, you might get some build issues. Okay, so now we did all the piping so that all of these work. We have our backend, we have our wrapper for QML. All we need to do now is to actually call it from QML. So now what we have available in QML is a QML type, which has the same name as this one here, as the C++ class, and that has the same functions. So all we can do is, well, let's do it so that when I switch the button on here, the LED will be on, otherwise it's off. So for this, I can again do a binding, and I used actually the signal handlers in QML. So switch as a signal, which is called, well, checked, changed. So on checked changed, I just called my signal function from my singleton, and I pass as arguments the checked state. Let's compile this and run it. Some issues. Okay, that should be fine. Okay, there's some issue. It is not working. So I must have made a mistake, but let's not waste time with this. Normally it should work and you should see the green light here turning on and off. All right, so and now the last step is to show you how you can do translation since this is supported. So this is also fairly easy. We have now one string of text in our UI, which is hello world, and let's say we want to translate that to several languages. So from the QML side, there's only really one thing you need to do. You simply need to mark all the strings that need to be translated. In this case, this one. And the only thing to do is to wrap your string inside a function which is called qstr, this way. If you add more, then you would do the same for all the other strings. And then again, in the project, you need to tell what translations you want to have. And for this is another CMake function you have available for Qt Ultralight, which is this one, Qt target embed translations. You pass the name of the project, and then here, for each translation that you want to have, in this case, I want to have French, you need to add a different file. You can just call it the name of your project, and this part is important. This is how you will tell which language to use. So typically use the code of the language and of the country, and the TS as extension. And when you do that, it will it allows to generate a special file, which is this one. You could do it from command line, but if you want to do it from Qt Creator, there's actually a CMake or build target which is generated. But to be able to run it, we can go here in the project settings and in the run part, build, sorry, settings. Let's clone this build configuration and let's call it update translation. And now if we go in the build settings here in the details, instead of doing the default build or using the default build target, let's select the update translations target. So that means that now if I select one of the debug or release, it will build, but if I select the update translation, what's going to happen under the hood is that the tooling will parse all your QML files, search for these QSTRs, and then from that generates the TS file. So if we have a look now at our project, there should be, you see this TS file. Right now it's empty. It does not contain any translation. So to do the translation, we can use the linguist tool, which is included with Qt. We can just open, this isn't, by the way, not mandatory. You could do it by hand as well if you want to, but I think it's a bit easier to use the linguist tool. And now you see we have only one string, but it would otherwise list all the strings, translatable strings you have in your application. And if you have multiple languages generated, it would also show all the different language options. And then you just need to type in your translation here in French. Let's mark that as translated. We can save. Just close this tool since we're done with the translation. And now we simply need to, well, somehow change the language. So for this, you have a Qt ultralight specific property that you can set, which is the, let me show it to you, fuel.ui language. So in this case, what I'm going to do, again, to keep the example simple, whenever my checkbox or switch button is off, I will be using the English language. And if it's on, I will be using the French language. So again, same behavior here. If it's checked, if the switch button is checked, then I use the French language. So this is the name I had set in my TS file, the language code. And if it's not checked, I will use the English. But in this case, I did not actually create an English translation file. English is basically just the language defined in the source. So in that case, I just set source language. And now I can just build and run. Okay, I guess this was why the LED did not work earlier. Okay, let's not try to debug this now since we're already a bit late. I will just remove this and run. Okay, so now it's in English. And if I switch on, you see that the text is automatically updated with the translation. So in this case, French. All right, so this covers really all the basics that you need in QML to create your application. There's much more you can do, but for that, I encourage you to read the documentation on how you can do more advanced things. One last thing which is worth showing is the debugging, because I actually showed you how to create the different kits to handle it. So very quickly, for debugging inside Qt Creator, you will need, as I said earlier, need to switch to a different kit, the kit we've configured for debugging. Make sure you use the debug build. And right now you need to manually start the GDB server for the board. So in this case, it's for ST, so you need to start the ST-Link GDB server. I already have now, you can, by the way, I will share the slides about what I'm doing now. So all this information will be written down, will be, I think, a bit easier. So you need to go inside by directory where the STM32Cube IDE is installed. And then you can run the GDB server in this way. I'm not going to detail all the options, but just say I need to reset the device. And now it's listening for connection. And now in Qt Creator, I should just be able to debug this. Let's just open the main file. The main file, by the way, is generated. So you will find it inside the build directory. Let's just run CMake. Let's open the hello world, which is actually the main file, main.cpp, it's the same. Let's put a breakpoint here. And now let's debug here. Since the GDB server is running, it should just connect to it and we can start debug this way. All right, so our breakpoints was triggered and you can just note down, all the different debugging functions you typically have. So you can step in, step over, and so on. One comment about this, at this point in 1.0, you can only debug C++ code, so you will not be able to directly debug your QML code here. But since all of this is actually, and I did not explain it, but the way it works is that when you compile, all of this QML code is converted to C++. So if you look at your build directory, you will see that there are C++ files for all of your QML files. So of course, that one you can debug. And that ends our webinar for today. We've seen all the different steps on how you can create your first Qt application for MCU. Hopefully this will be helpful to you and you will be able to create your own. We will have now some time for questions, maybe not too much because I see we are a bit late.
Yeah, we have about 10 minutes or so. Thank you, Johan, for questions.
All right. So I've got a question, which is Python supported in Qt for MCU? So Qt for MCU no, is only supporting QML and C++. You cannot use Python to debug for Qt for MCU. Then we have a question, which is it possible to use Qt for MCU with an open source license? So no, Qt for MCU is only available with a commercial license. So if you need to use that on your project, please contact us and we will discuss all the details with you. There was a question about how to debug. I think we've covered that in the end. Then there's a good question, which is it possible to use Qt Design Studio to generate the QML UI files? So this is kind of a trick question. So it is, in a way it is, simply because it's QML. So of course, any QML code which is generated from Design Studio will be QML, so it can work, except that Qt for MCU has some restrictions. You do not have access to all the APIs that you normally have in normal QML. And today, Qt Design Studio does not have any way to restrict you in what QML you can use. So this is basically the limitation today. You would need to make sure yourself that you do not use any of the features that do not exist on Qt for MCU. Otherwise, of course, then the QML language, the generated QML can be reused as long as you respect these rules. And by the way, this is on the roadmap for Qt for MCU. We will in the future release support or enable basically this in Qt Design Studio so that you can easily basically restrict the QML language to what you can use on Qt for MCU. Then there's a question about the virtual keyboard. So if there's one included in Qt for MCU, as of today, there isn't any included. So either you could implement that yourself or there's no such thing as of today. But this is also something which is considered for future releases. Then we have a question about, is there any possibility to rotate the screen? So this is also possible, but with some, basically, at least as of today, it's not doable from QML directly. So one comment here, I didn't show it, but you can apply transformations to items in QML, for example, rotation. So in normal QML, you would be able to do this by just rotating the root item. But this is not possible in Qt for MCU. You can only rotate images and text. So a way you could do that is to really just rotate the whole content of the frame buffer. And I would say this depends on the hardware. For example, if you're using NXP, you might be able to use PXP to rotate the content. Or you could also, another way, this is a bit more cumbersome, but you could just rotate all your assets so that if you need to have all your UI in portrait, even though the screen is in landscape, you could just rotate all the assets and then it's shown this way. This is, again, by the way, a topic that we are currently researching on how to support this easily inside of Qt for MCU. Then we have many questions. We have a question which is there any plan to support SoCs with GPUs? So again, today the scope of Qt for MCU is microcontrollers. So that means Cortex M7s and Cortex M4 today. Typically, these processors do not have a GPU. But I'm saying typically because there are some kind of exceptions, at least some of the ones we support, like the Renesas RH850, it does have some vector-based hardware acceleration, but that's only for 2D. And this is, of course, something that we want to leverage inside of Qt for MCU so that you can get even better performance when using these kinds of microcontrollers. But again, otherwise, most of the microcontrollers we support typically do not have such features. Then we have a question about networking support. So is it possible to use Qt APIs for sending and receiving data over network? So no, this is not possible today because, as I said, Qt for MCU only includes GUI functionality. So if you need to use anything else, for anything else than graphical user interfaces, you would need to use third-party APIs. Typically, often board vendors provide APIs to do, for example, networking. Then there's a question about if Qt for MCU will support QMake in the future, and the answer is no. Qt for MCU will be only exclusively based on CMake. And a side comment on this is true for Qt in general. If you haven't been following news on Qt in Qt 6, we will also switch all of Qt to CMake instead of QMake. Then we have a question, is it possible to start the application from a C++ file instead from a QML file? And the answer is no. Today, the main entry point in a Qt for MCU application is always a QML file. We have some other questions about is it mandatory to use the Microsoft C++ compiler or MinGW is suited as well? Actually, you do not need any of these. Technically, if you want to use, if you only want to compile for the target board, you only need GCC for ARM basically. When you will need the C++ compiler or the Microsoft C++ compiler or MinGW, that's only if you need to or to test your application also on desktop because this is supported. So in this case, yes, you will need, and it can work with, I'm not actually sure now if it's both or just Visual Studio, but anyway, you will need one of the two. There's a question about someone asking how can other boards being used, like for example, the STM32F746G. So for any board that we do not support out of the box, then we can basically port the Qt for MCU package to any other board. So typically in this case, if you want to use that board, you would need to contact us. And we can discuss how we can port this as a service for you. And I will take 2 extra questions, even though I'm sorry we have even more questions, but I don't think we will have time to answer all of them. So I will take 2 extra questions, and any extra ones, please forward them to us, and then we can answer to you by email. So the next question will be, is it possible to use data models in C++ to the QML language? And yes, this is possible. I did not show it today. So in addition to exposing your C++ code through objects and singleton, you can also use list models. It's a Qt for MCU specific API, but it's there and you can do it. And then the last question, which I think is important to answer, is about basically how does Qt4MC work in this case on bare metal, and does it include a scheduler for multitasking? So the answer simply is that it doesn't. When you use Qt4MCU on bare metal, there is no task scheduler. So you would have just one single thread of execution, and then you need to take care of anything that needs to be synchronized or not. But this is why we're currently working on porting Qt4MCU as well on different real-time operating system for MCUs. So the first one we will support and that we are currently working on is FreeRTOS. So of course, then if you use FreeRTOS or Qt4MC on top of FreeRTOS, that means that then you have a scheduler and you will be able to use threads. So there will be a C++ API in Qt4MCU to create threads and then to potentially do different stuff, like for example, for connectivity inside a separate thread, while the UI will be done in another thread. So again, this will be enabled by the support of real-time operating systems like FreeRTOS. And yeah, again, I'm sorry for not answering all the questions, but please forward to us all of the questions and we will make sure we answer all of them by email. Thank you.
Thank you, Jan. Yeah, like Jan mentioned, if unfortunately we run out of time today, but if you have more questions that we didn't go over, please send us an email at info@qt.io and we'll answer them for you then. But thanks again, Jan, for your presentation, and thanks again for everyone for joining, and I'll see you next time.